Chem 2, states of matter. So you may have heard about the different states of matter before, and we're going to be looking at our three main states of matter in more detail. Solid, liquid, and gas are three states of matter, and anytime that I think about the states of matter or how they can change from one state of matter to another, I always think about water. So we know that water exists in a solid state as ice, water is a liquid as water, and water also is a gas as water vapor. So one thing that we're going to be looking at is the term volume. So volume is referring to the amount of space that something takes up. So volume is the amount of space that something takes up. So a solid is going to have definite shape and definite volume. So what that means is that it has a specific shape and it also takes up a specific amount of space. So in this picture, we have the molecular structure of a solid. You can see the particles are packed closely together and they vibrate in place. So these little lines indicate that the particles are moving around. They just kind of shake a little bit. They vibrate in place. So they're not completely still. There are two types of solids, amorphous and crystalline solids. So our first one to look at is crystalline. Just like the word crystalline has the word crystal in it. So a crystalline solid is going to be made of crystals. It is going to have a regular repeating pattern. And there are a couple examples that I have on this slide for you. So this first one is salt. Salt crystals, sodium chloride, are kind of cube shaped. So that is your first example. And then another example is amethyst. Amethysts are a type of quartz. It's a purple quartz, so it's made of silica. And this is another one that you may be familiar with. Amethyst is used a lot of times in jewelry as a precious gemstone. And the second type of solid is amorphous. If you use your stems, A means without, and morph refers to the shape or form of something. So an amorphous solid is going to not have a specific structure within it that makes it have a crystalline shape. So it's not going to have that crystalline shape. It's going to be without a specific structure in terms of the molecular structure. So I like to think of amorphous solids as kind of globby solids. Candle is an example. Butter is an example, cotton candy is an example, and all of these are really going to be affected by increases in temperature. So if you light a candle, it's going to end up melting, and it's going to be something that is kind of modified by an increase in temperature. Liquid is the next state of matter. So liquid is not going to have a specific shape because it takes the shape of whatever container that it's poured into. But it is going to have a specific volume. So it takes up a specific amount of space. So if you look at the image here, you can see some little lines and some arrows that are around these particles. So this shows that there is movement within the liquid. So these particles are going to be able to move freely. They move around freely and spread out in the container. And since we know that gravity pulls stuff downward, whenever you put a liquid into a container, it's going to fill up the container from the bottom upward. So that's why we don't see those particles up here at the top of the container, because they filled up from the bottom of the container up. One term that describes a liquid's movement is viscosity. So viscosity refers to a liquid's resistance to flowing, how resistant it is to moving. And you can think of that as how fast or how slow the liquid moves. So if something has a high viscosity, then it's going to flow really slowly. It's going to be really resistant to flowing. Honey is an example, syrup, molasses, so substances that are really thick. Some other examples with high viscosity are going to be like mayonnaise, for example, or conditioner, something that is in a squeeze bottle. So it applies that force of squeezing the bottle to get that particular substance to exit the bottle. Ketchup is another one. Ketchup in those glass bottles where you have to like beat the ketchup bottle on your hand to try and get the ketchup out. So that's another great example. Liquids with low viscosity are going to flow really quickly. These liquids are not going to be resistant to flowing. They'll spill really easily. Water, vinegar, those are some examples. Milk, juice. So anything that would spill really easily and really quickly, those are going to have low viscosity. The last state of matter is a gas. So gases do not have definite shape and they do not have definite volume. So they don't have a definite shape. They will take up the shape of the container that they're in. So if you put helium into a balloon, that helium is going to spread out to take the shape of the balloon. And it will fill all the space that's available to it. So gases are going to have so much energy that they literally are bouncing around. They're bouncing off the walls. And that's why you see these kind of streaks behind each of these particles. So gases also don't have a definite volume because since they take the shape of their container, they're going to spread out, and whatever container it's in is going to take, the gas will take the shape of that container and the volume of that container as well. So let's put that into a real example. So let's say that there's a chemical reaction that's done in a test tube. If you have a lid on the test tube, that's one scenario. If you don't have a lid on the test tube, that's a different scenario. So let's say you put a couple substances in here that reacted chemically, like vinegar and baking soda, for example. It produces a gas, which gets released, and you hear fizzing, and you may even see some little smoke-like particles entering the air. So if you have the test tube on, all that's going to get trapped in the test tube. That would be a closed system. If you have the test tube off, that's going to be an open system. So what do you think is going to happen to that gas that's produced if you don't have a test tube lid or a top on the test tube? The gas that's produced is going to escape into the air. So you would have this kind of scenario going on. The vinegar and baking soda would be mixed, chemical reaction occurs, bubbling, fizzing, and any of that gas that is being produced is going to be released into the air. So if you have a chemical reaction that's taking place that produces a gas, if that is done in a closed system, it will trap the gas. If it's done in an open system without a lid, then it will be released into the air. So let's look at a couple different examples for states of matter. So these plastic bottles, solid, liquid, or gas, those are going to be solids. They're amorphous solids. Those are empty, but if you think about those as having water in them, the water would of course be a liquid. Ketchup, we already said ketchup a few minutes ago. It's liquid. It's going to be high viscosity liquid because it doesn't pour very easily. Soda. So if you think about soda, this one's kind of a trick. So the bottle is a solid. The liquid part is the soda, but also it has carbon dioxide. Carbon dioxide is a gas, and that is forced into the soda bottle to make it fizz. When you open it up, you hear that nice little tsh, and so that is the release of the carbon dioxide gas. That's what makes it so bubbly. And if it is flat, then that means some of that carbon dioxide has gotten out. It has escaped. Glass. So glass is going to be a solid. French fries. French fries are solid. They're an amorphous solid. Lava. So lava, when it is at a super high temperature, lava is melted rock. So it is liquid. It's a very high viscosity liquid. And when it cools down and gets to the ambient temperature of the air around it, then it will harden into a solid. It will harden into a rock, an igneous rock. And our last one, ice. So ice is a crystalline solid. It has a specific form when it freezes. But remember, ice is liquid water. It's frozen. And so this ice is just water that has frozen. If it heats up, then it will change in temperature and it will turn into a liquid. And then if that liquid continues heating up through boiling or evaporation, that vaporization process, then it's going to turn into a gas.